In this video, we're going to be talking about maximum and minimum values. So for the quadratic function f of x is equal to ax squared plus bx plus c, the y-coordinate of the vertex is the maximum value when a is less than 0, or in other words, when a is negative. And minimum value when a is greater than 0, or in other words, when it's positive. And we can find the maximum and minimum value without graphing when we just plug in our x coordinate of our vertex into our function. And so the maximum / minimum value is always going to be f of opposite of b over 2a. So let's look at some examples of finding our maximum or minimum values. So we're going to find the maximum or minimum value of each function. So I'm going to first determine, okay, is this going to be a maximum or is this going to be a minimum? So I need to see, okay, is my a value positive or is it negative? Well, if I'm labeling my a, b, and c, I have that my a is 1/2, my b is -2, and my c is -1. So here, since a is equal to 1/2, which is greater than 0, this is going to be a minimum. So now let's go ahead and find that value. So finding it, it's almost like we're finding the vertex. So I need to first find my x value of the vertex and then plug that in to find my y value, because that y value is going to be my minimum value. So I have that x is equal to the opposite b over 2a. Well, b here is -2, so the opposite of -2 is +2 over 2 times a, which is 1/2. 2 times 1/2, I just get 1. So I have that x is equal to 2 divided by 1, which is just 2. And now plugging that in to my function, f of 2, I have 1/2 times 2 squared minus 2 times 2 minus 1. 2 squared, I get 4, so I have 1/2 times 4 minus 2 times 2, which is 4, minus 1. 1/2 times 4, I get 2 minus 4 minus 1. Well, 2 minus 4 is -2. -2 minus 1, I get -3. And so here I can say my minimum value is -3. Okay, let's look at another one. So here I have f of x is equal to -4x squared plus 16x minus 3. I'm going to go ahead and first label my a, b, and c. So I have a is -4, b is 16, and c is -3. So here my a is equal to -4, which is less than 0. So since this one is negative, that means that this is going to be a maximum that we're finding. So let's go ahead and figure that out next. So I have x is equal to the opposite b over 2a. My b value is 16, so the opposite value of that is -16 over 2 times a, which is -4. 2 times -4, I get -8. And so here I get that x is equal to +2. So plugging that in, f of 2, I have -4 times 2 squared plus 16 times 2 minus 3. 2 squared, I get 4, plus 16 times 2 is 32, minus 3. -4 times 4, I get -16. -16 plus 32, I get 16. 16 minus 3, I get 13. And so the answer for this one is maximum value is 13. So let's look at an application problem where we are using maximum minimum values. So this problem says a model for the performance of a stock is P equals negative 3D squared plus 50D, where D represents the days of trading and P is the price per share. What is the maximum price per share of the stock? Well, we just talked about how to find maximum. I need to plug in the x value of my vertex into my function to find the y value because I know that's going to be my maximum. So I need to first find x, which is opposite b over 2a. Here my a is negative 3 and my b is 50. So the opposite of 50 is negative 50 over 2 times a, which is negative 3. And so I get negative 50 over negative 6. And then when I go ahead and divide 50 and 6, I get that x is equal to, I'm just going to go ahead and simplify that fraction to get 25/3. And now I need to go ahead and find my y value there. So I have negative 3, 25/3 squared plus 50 times 25/3. So 25/3 squared, I'm really just doing 25/3 times 25/3. And when I do that, 25 times 25, I get 625. And 3 times 3 is 9. Plus 50 times 25, I get 1250. Multiply that fraction, I get negative 625 over 3. Which ends up being 625 over 3. And so I'm going to go ahead and switch that over to decimal form. So when I do 625 divided by 3, I get that the price per share is approximately 208.33. Okay, now part B says another company used a table to represent the data for their stock prices, which has a higher price per share. So looking at this table, I see after 3 days, the price is 198. After 5 days, the price is 200. After 7 days, is back to 198. And after 9 days is 196. So again, we need to look at when we graph a parabola, what does it look like? Well, we know it looks like this, where there's a peak, which is our vertex, which is where our maximum is happening. And we see that the points are reflected across that x-axis, where our y values here would be the same. So I see that I have the same y value here of 198, 198. And I see that point in the middle is a little bit higher than that. And so that means that this point in the middle, where I see on either side of it, my y values are repeating, is my vertex. And the maximum happens at the y value of the vertex. So here, the max is 200. So this one's $200 per share for this company. And so now I need to compare. Well, $200 is less than the 208 that we found above. So this one would be the first company, has a higher price per share.